Assalamu alaikum students. Today we will discuss the rest of the question of the lesson isotopes and AR. Okay. Now while discussing the answers, please write them in your laptop. Okay. In the last class we discussed question 1, 2, 3 and 4 of the page 13. And today we will see what is the answer for question 5 and 6 in the same page 13. Right. Question 5 is asking you, what does the term mean, atomic number or mass number? Student, this question can come in a question paper like this. What is mass number? What is atomic number? What do you mean? Or you maybe ask, write the definition of mass number, atomic number. They're the same thing. What does this mean? What is the definition? Same thing. Definition means as given by the scientist. Okay. Question First one, A. Atomic number. Yes, atomic number. You cannot change the definitions. Remember, definitions are given by the scientist in the scientific field. We cannot change them as we want. Right. Atomic number is the number of protons in an atom. It is also called the proton number. Right. The number of protons in an atom, the number of protons in an atom is called the atomic number. This has another similar name, atomic number. This also called atomic number is also called the proton number. Atomic number is also called the proton number. Please learn. If you don't know that atomic number and proton number similar words, you will confuse at the exam. Then this is special point, right? We can identify an atom. We can identify an atom by its atomic number. Right. Please write if you do fast. Atomic number. The number of protons in an atom is called the atomic number. Atomic number is also called the proton number. This part is the definition, and this is the special point what we can do. This is this. We can identify an atom by its atomic number. Okay. Next question is, what is mass number? Question number B. Yes, we know only proton and neutron has a mass, electron has zero mass. So mass number should be formed together by protons and neutrons only. Then that is the definition. The number of protons and neutrons together. Boys and girls, please listen. The word and mean plus here. Remember, if you change a word and definition can change, okay? The number of protons and neutrons. The number of protons and neutrons in the atom is called, the number of protons and neutrons in the atom is called mass number. You can write it also in as a formula also, like this way. See, You can write the same thing as a formula. Mass number equals proton number plus neutron number. As a formula also you can write either by word or this way. Or you can show it this way. Same thing. Proton number plus neutron number. Right. Name each of these atoms and say how many protons, electrons and neutrons it has. Okay students, if we know the mass number and atomic number, we can find the number of neutrons in an atom also. This is also shown in your textbook, and also mass neutron number equal mass number minus atomic number. Okay. And question 6 we will do as a table, right? Okay, question B, 5 answer A, B finished. Now write this as a small note, not for this answer. As before going to question 6, you should note this thing, note, special note. We can find neutron number as follows. Neutron number equal, neutron number in the atom is equal, if we know the mass number, and atomic number, we should minus atomic number from mass number. Write this as a formula. Okay? Neutron number or the number of neutrons is equal mass number minus atomic number. This is minus mass. You should deduct atomic number from the mass number. For example, right here, sodium, right, dash, mass number, write an example, 23, atomic number, 11, find neutron. Neutron number or number of neutrons, same thing. This is special note, okay? This is not for question 5. Without knowing, you can move to question number 6. We can find neutron number as follows. Neutron number or number of neutrons, same thing, equals to the mass number minus atomic number. Example, sodium mass number given 23, atomic number given 11. Find neutron number. Okay, it's easy. So, I will write the answer up. Okay, see here. Number of neutrons in sodium. You are given the element name, so write the element name in your answer. Equal number of neutrons. How to find? Mass number minus atomic number. Mass number minus atomic number. What is the mass number given? 23. Okay, minus. What is the atomic number? 11. So number of neutrons in sodium is 12. So give comma. Number of neutrons in sodium, answer is 12. So, question. Right? So answer will be 12. Right. Now you understood it. Okay, now let's move to the question number 6. Please follow the instruction I am giving you for question number 6. Don't copy the question, everything what is given in the book. You copy it like this. Put the question number in your laptop in question 6 and question 6. Write question 6 only. Then you divide your book into, they ask you to find you how many protons, electrons and neutrons it has. Yes. And first page for, first line for the element. Right. You will make a table. Okay. And this side you will copy the given data, that is element symbol given, you will copy them here, and you are asked to find protons. Here you will copy the what is the data given in your table. Protons, electrons and neutrons. Protons, electrons and neutrons. Right? Okay. Then how many lines you should take down? 1, 2, 3, 4, 5. You have given 5 elements, give one line gap. So you take 10 lines down only. Number 1 is carbon 12. Please see students, you must write 12 up and 6 down. Carbon 12 and give one line gap. Give a one line gap here. And then go to the number 2. Number 2 is oxygen 16, 8. Give one line gap. And number 3, magnesium. Clearly write, give one line gap please. Otherwise it will be congested in your book. Number 12. Right. And number 4 is aluminium 27 and 13. Right? If I write down, I think you cannot see the last one. Okay, no problem. I will do the last one up again. The last one is copper 64, 29. Copper 64, 29. Right. Don't worry. Okay, now you have copied the data given in the question, and then we have to find the electrons and neutrons and protons. Okay. What is this upper number? The bigger number is the mass number. Lower number is the atomic number. What is the meaning of atomic number? Atomic number is the number of protons in an atom. And number of protons and electrons are equal in any atom. So, proton number is the lower number. Okay, carbon has 6 atomic numbers, so proton number 6. Oxygen has 8 atomic number, so its proton number is 8. Magnesium atomic number 12, atomic number means proton number, so it is 12. Aluminium atomic number is 30, so proton number is also 30. Right. We know every atom has equal number of protons and electrons. So protons and electrons, say 6 protons means 6 electrons, 8 protons means 8 electrons, and 12 protons means 12 electrons, and 13 protons means 13 electrons. And copper has 29 protons, that means it has 29 electrons also. I think you can see the last line. Isn't it? Okay, I will tell. Copper, upper number is 64, lower number is 29. That means mass number 64, atomic number 29. Atomic number means protons and proton number 29. Every atom has equal number of protons and electrons. So proton number is same as the electrons. Clear? So carbon 6 proton, 6 electron, oxygen 8 proton, 8 electron, magnesium 12 proton, 12 electron, aluminium 13 electron and 13 proton, and copper, this is 29. 29 proton and 29 electrons. Clear? Okay. How to find the neutron number? Yes. Okay. You can do the rough in the side and show. Oh, I will do it here. Right. To make you understand, I am doing the calculation just here. How to find the neutron? Mass number minus atomic number. Mass number 12 minus atomic number 6. 12 minus 6 is equal to 6. Here mass number is 16. 16 minus atomic number 8 equal 8 neutrons. And magnesium 24 minus 12 equal 12. And aluminium 27 minus 13 equal 14. Right. And copper 64 minus 29 equal 5 minus 2, 35. Yes, it has 35 neutrons. 64 minus 29, 35 neutrons. Clear, boys and girls? And this side, I show you how to find it to make you understand. So you follow it in the same way. So later, when you follow your lessons, you will not make any misunderstanding or mistake. 12 minus 6, 6. 16 minus 8, 8 neutrons. 24 minus 12, 12 protons. 27 minus 13, 14 protons. 64 minus 29, 35 neutrons. Okay, please follow up. All right. I think now you have a good understanding regarding what to do. All right, students, please listen to me. I told you in the previous class also, the elements coming in your syllabus, first 20 elements, especially electronic structure we will give. You will learn only certain elements of these. I asked you not to memorize the elements in the periodic table. You need not to memorize all the elements in this transition block. You need not to memorize them. Some elements are coming and symbols in the question answer. You memorize only those elements. Don't ever try to memorize all these 120 elements hard. That's not necessary. Only first 20 elements, names and symbol and atomic number if possible. 1, 2, 3 possible. And the transition methods, some element names and symbols are coming in the question, only that. Other things, don't try to memorize hard because some student has a misunderstanding as well as your guardians also. No need. You need not to memorize these all the elements in the transition block. That is not necessary. Please remember that. Okay. All right. Okay. Now we have discussed the question answer of page 13. Now let's move to the next chapter. 1.04. According to the serial, next chapter is 1.03, but we will do it later and we will do 1.04 first. How electrons are arranged. It is the same thing already we discussed, but here first 20 elements electronic structure is illustrated and drawn. Okay, carefully listen to me. In this chapter also there are certain theories which is very important. Yes. Okay. Electrons are already arranged in shells, we know, and shells are called energy levels. Electron arrangement. They are arranged in shells or same thing, energy levels. These two terms are similar. Yes. 1.04. Yes. And first shell is the lowest energy level. First shell is the lowest energy level. Student, electrons in the first shell has very less energy. And further the shell, energy increases. Right. Please underline these two lines in your book, the second paragraph. Right. Okay. Let me remind you. The electrons in an atom circle very fast around the nucleus at different energy levels. Energy levels are called also electron shells, right? The first shell closest to the nucleus is the lowest energy level. Please underline. The further a shell from the nucleus, the higher the energy level. And also the second line. These two line theories are very important. Second para, both the lines. Okay, students, electrons are always trying to occupy the lowest possible energy level. So lowest shell is first shell. So electrons occupy first shell and then the lowest level is second shell and so on. This is the rule they follow. I told you electrons are following a rule. They fill the first shell first and then go to the second shell and then third shell and then fourth shell. Yes, they follow this rule always. If they can occupy the first shell, they will not go to the second shell until first shell complete. If the second shell is complete and cannot be occupied, then only they will go to the third shell. Simple. Simply you must remember that electrons are always occupying from first shell to outside because first shell energy is the lowest energy. That's it. Right. And here, student, in this diagram, they have used crosses. You can either use a cross or a dot to represent electron. Electrons are saying we are using dots and crosses for our benefit, right? For our clearance while drawing this thing. Dot and cross, that is the electron is same, right? And Niels Bohr is the scientist who first give the ideas about shells. Niels Bohr in 1960, he died, right? He's a Danish scientist. Remember these important personals' names also for short question and also for your knowledge. If you don't know any scientist and as a students who are learning science, that is, it is not good for your personality. You should know the names of scientists which come across in your lessons and who has done a great work for the science, for the improvement of science. Right. Okay, so the electrons fields are from the first shell to the outwards, right? Okay, again here given the first 20 element in the list, see students, and there are three elements underlined. That means that elements, they are shells, last shell complete. See, first two element is hydrogen and helium in the periodic table, and helium first shell fill. And from lithium to neon, that is the second period, and neon, last shell is complete. That means second shell complete. And then sodium to argon, third shell filling is done. That means third period, and it is argon, third shell complete. After that, you will get two elements, which is which has 4 electrons, that is potassium and calcium. Right. Students, the element, if its outer shell is complete, that element is unreactive. Actually, elements are reactive to get electrons, to fill electrons to their outer shells. Elements are reacting, atoms are reacting to get the electrons complete in their outer shell. If any element has a complete outer shell, that element need not to react. So it is unreactive. That is why group 0 in the periodic table we call them noble gas, and noble gas do not react because their outer shells are complete. Okay. Electronic configuration of the periodic table. Electronic configuration means arrangement of electrons in each shell. Right, at first 20 element is given. Electronic configuration means arrangement of electrons in each shell. Electronic configuration means the arrangement of electrons in each shell of the atom. Right. Students, please see in your this textbook, page 17, there is a table. This table has some printing mistakes. Please follow it as There are some 5 important points below the below the diagram, and see the important points you are learning. The shells fill in order, starting with the inner one, that means lowest energy level first, and all the elements in a group have same number of electrons in their outer shell. The group number is same as the number of electrons in the outer shell. The elements in the group 0 noble gases have full shells. The period number shows how many shells of electrons there are. The same theories we discussed. This is the most important rule or theories you have to learn. Group number equals to the number of electrons in the outer shell of the atom. This is a rule or theory. So group 1. So example, then group 1 element has 1 electron in the outer shell. That is true. See, sodium 281, lithium 21, potassium 2881. That is their theory. See, go to the group 1, see. Hydrogen is given, hydrogen is not a metal, so we don't consider it. And lithium 21, sodium 281, and potassium 281. So group 1, they have 1 electron in the outer shell. The other theory is period number is equal to the period number. This thing is very important. These two rules are important. Period number equal to the number of shells. Number of electron shells, not just shells. Number of electron shells in the atom. Atom represent is specific element, so in the atom means it's element, right? Now again go to the table given to you. The first period, it is mentioned in your left hand side beside the boxes number given. Beside hydrogen, period 1 given, and it is hydrogen, and from that 1 you come to the right hand side, then you will meet the helium from group 0. Period 1 contain only 2 elements, that is hydrogen and helium. Right. Period 2, start from lithium 2 and end up in neon. Neon C, outer shell complete. Right. And then comes the third shell from sodium to argon. Argon C, outer shell complete 288. And fourth period is potassium and calcium 2881, 2882. That means 4 shells. So this rule is correct. Period number is equal to the number of electron shells in the atom, and group number equals to the number of electrons in the outer shell of the atom. So using these two theories, they have put into the groups. And group 0 element, group 0 means outer shell complete. So they are not reacting, they are outer shell complete. The outer shell complete. Alright, in the next class, we will discuss the question answer of this chapter. Today we will stop discussing from here, and please student, in the diagram of the given page 17, electronic structures are correct. There are few diagrams, they are inside electron number, they have printed wrong. So diagram is wrong, but the written number below is correct. So you should always follow the number given below. Look at number 6 carbon. Number is 2, 4 given, but in the second shell they have drawn 3 electrons. Okay. So diagram is wrong. You have to correct the diagram. Okay, there are a few mistakes like that. The electronic structure given below is correct, but the diagram is electron number is wrong. So don't follow the diagram. Please draw the diagram according to the number given. Okay. Thank you. We will see in the next class.